Hello, 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 hello. Tadi kerja. Hello, cek. Hello.
Artika,
Yes, ma'am.
you can start the session now.
Okay, ma'am.
So, good evening. Shivraman sir.
Yes, ma'am, I am here.
Okay, sir. We shall start the session, sir, with a formal intro.
Good evening, everyone. It's a great pleasure to welcome you all to today's faculty development program on NLP application using machine learning and deep learning techniques. Natural language processing, or NLP, is one of the most exciting fields in artificial intelligence today. From voice assistants and chatbots to language translation and sentiment analysis, NLP is transforming the way we interact with the technology. With the power of machine learning and deep learning, computers can now understand, interpret, and even generate human language with amazing accuracy. This FDP will give us a valuable opportunity to explore how these technologies work, the latest tools and the techniques in the field, and how we can apply them in the research and real world projects. We look forward to an engaging and insightful session. Chief guest interaction. It gives me an immense pleasure to introduce our esteemed chief guest for today's faculty development program on NLP application using machine learning and deep learning techniques. Dr. Shivaram Rajayagiri is a distinguished academician and currently serves as an associate professor at the College of Computing and Information Technology in the Kingdom of Saudi Arabia. With an extensive background in machine learning, deep learning, and natural language processing, Dr. Shivaram has been at the forefront of the research and innovation in the domain of intelligent systems and AI-driven solutions. His academic contributions have not only enriched the learning ecosystem in Saudi Arabia, but have also inspired scholars and students globally. A passionate educator and a dedicated researcher, Dr. Shivaram is known for his insightful lectures, collaborative research initiatives, and commitment to excellence in the field of computing. We truly honor to have him with us today to share his valuable insights and expertise. Please join me in welcoming Dr. Shivaram Rajayagiri. Sir, now the session is over to you.
Shivaram, sir.
Yeah, sorry, actually muted.
Yes, sir.
Now
You
is it?
can take over the session, sir. We are very happy to have you today.
Thank you. Is it audible?
Yes, sir. Your voice is audible.
Okay, thank you very much. Okay, thank you very much, madam, and good morning, everyone. It gives me great pleasure to welcome you all to the International Faculty Development Program organized by the Internal Quality Assurance Cell and School of Computing at DAY-2 Institute of Arts and Science. And I am very much pleased to be one of your resource person. I am privileged to be with you. I am Professor Suran Rajayagari from Shakra University, Saudi Arabia, and I will guide you through these exciting areas. Let us make the most of this session by engaging actively and exploring new pathways of innovation and research in computer science. Okay, thank you to the organizers giving this opportunity. Now we'll start our session. Here I am going to provide an overview of key concepts in natural language processing and machine learning, which are fundamental areas in artificial intelligence. Here we go with introduction to natural language processing, where we will find overview of NLP. That is, think of NLP as teaching computers to understand and interpret human language, like chatting with a virtual assistant such as Siri or Alexa. For example, when you ask Siri, what is the weather today? And NLP helps Siri understand your question and fetch the weather information. So like that, this NLP will be used by Siri and Alexa. And the key concepts and the terminology, we include the tokens, syntax, semantics, like how words from sentence, and also we are going to discuss about the history, context and evolution, where NLP has evolved from simple word matching to complex models like ChatGPT, and also we discuss about applications in industries that used in customer service chatbots, translation apps like Google Translate and Voice Assistant, and also we are going to discuss about the fundamental of machine learning and deep learning, where this machine learning lets computer learn from data without being explicitly programmed, like predicting what movie you might like based on your past choices, and email spam filters that learn to identify spam emails over time. So whatever you are talking nowadays, well, whatever you are talking to each other or to anybody, our mobiles are listening to us, and they are giving some unnecessary advertisements to us, where we didn't expect that advertisements how they came. So like, and also we are going to discuss about the difference between the traditional ML and DL. The traditional ML uses algorithms like decision trees, while deep learning employs natural neural networks, more like how the human brain works. And the key algorithms and modules includes regression, classification, neural networks like deep learning models using image recognition. And also we discuss about the supervised versus unsupervised learning. Supervised learning is like a teacher giving labeled examples, example identifying cats and versus dogs. Whereas unsupervised learning finds patterns without labels, like customer segmentation. Like, okay, well, finally, this natural language processing helps computers understand language, and machine learning and deep learning are techniques that allow computers to learn from data to perform tasks such as translating languages, recognizing images, or predicting customer behavior, like that. And continuation of this, we are going to discuss about the text-free processing techniques, which involves preparing raw text data to provide the performance of NLP models. Examples includes like tokenization. What is the tokenization here? Like breaking text into words to tokens. Anyhow, we are going to practicing hands-on experience. Like I will execute some program. How this tokenization will be done through the using like Python language. Suppose, for example, natural language processing becomes like 3 tokens. Natural language processing, like, okay, like that we'll discuss about stemming and limitation. That reduces words to other root form, like running and ran. Both comes run. So like that. So there is some practical exercises that we are going to practice now. So from the hands-on session, implementing pre-processing techniques using Python. And NLP machine learning techniques, it involves applying machine learning algorithms to NLP tasks such as data flow and term frequency inverse, document frequency, that is a TF-IDF, methods to convert text into numerical features. For example, a sentence, I like apple, suppose, I like apple, and I like oranges. The bag of words, BOW counts how often each word appears. So this is actually a TF-IDF you do, and then by a simple probabilistic classifier. Yes. And SVM and other ML algorithms used for tasks like text classification. That is, for example, sorting customer reviews into positive or negative sentiments, and sentiment analysis and text classification will be there. That is determining whether the text expresses positive, negative, or natural feelings For example, analyzing tweets to identify public opinions on a product. And we have some programs developed in Python, like hands-on experience. We will have hands-on session. That is pre-processing, implementing techniques like tokenization with Python's analytical library. We import the analytical library to implement this tokenization program in Python, and sentiment model building using Python's scikit-learn to build a sentiment classifier with example data. So, like this, we are going to have an experience with your programming execution also in this session. And we will learn about deep learning for NLP. That is introduction to neural networks and deep learning. Neural networks are computational models inspired by the human brain that recognize patterns in data. Deep learning is a subset of machine learning that uses multi-layered neural networks for complex pattern recognition. So these are for this we can have an example that is imagine training a neural network to recognize the handwriting digits. Once any new handwriting digits distinguish between like a 3 from a 5 or 1 to 7, such some confusing, some 6 and 8. Sometimes that differentiation should be identified. That will be recognized as the handwriting. And we have word embeddings using word to vector and global vector and fast text. These are techniques to convert words into numerical vectors, computing their meanings and their relationships. Because in this deep learning, in the text, every word in the text, every word will be assigned with a vector, and with that vector there will be a numeric value will be given. That is a numerical vectors will be given. So while we are doing the practice on Python, definitely I will show this situation where it will be applicable. In word embedding, king and queen are opposed in vector space. Similarly, Paris and France are related, helping models understanding language context. And we have recurrent neural networks, RNNs, and long short-term memories. That is, RNNs can process sequences of data like sentences, and long short-term memory, that is LSTMs, are a special type of remembers information over longer sequence. For example, predicting the next word in the sentence. Suppose like the cat chased the. See, as predicting what will be the next word. The model can suggest most based on the previous words. So in the previous experiences, that means that database, it can be predicts that there may be a mouse. So like that. We have attention mechanisms and transforms. Attention allows models to focus on the most relevant parts of input data. Transforms use these concepts to process language effectively. For example, in translating a sentence, attention helps the model focus on the right word in the input to process accurate output. Okay, anyhow, this will be shown in an example while we are going to discussing this topic with the programming part. and we have to discuss about again advanced NLP applications and case studies, where the identifying proper nouns like person, location, organization names in text. For example, suppose Shivaram was the president of some Kenya. Recognize Barack Obama, suppose no, not me. I can take some standard example like in Barack Obama was the president of the US. Recognize Barack Obama as a person and US as a location. So this is the like named entity recognition. There we have what is this person name or location or organization name, like that identifying. And mission translation. Mission translation is automatically translating text from one language to another language. We have a good example like by if you type like hello, how are you, then it will be shown in other languages like French, suppose say bonjour, comment, kawa, like there is that. Okay, anyhow, I will show our Indian language translation. Yeah, there is a Python program where we use this mission translation, and we have question answering systems, building systems that answer questions based on a given context. Like a question, who wrote 1984? So by that you can say George Orwell. Like so, like case studies of NLP in real world scenario, we have applications like chatbots, sentiment analysis for customer reviews, or voice assistants. These are all the case studies for NLP assistants in real world scenario. And for this, we have creating a basic conversational AI that can represent to user questions, right? And the feature trends in NLP, that is emerging trends and technologies. Emerging trends include more advanced transformers, multimodal NLP combining text and images, and more personalized artificial intelligence AI. And next we will discuss about NLP core concepts. What are the core concepts in this NLP? Already I told you about this tokenization, that is breaking down text into smaller units called tokens, like words, phrases, or symbols. For example, if you say hello world, like it's naturally right now, then hello, and in between there is a space. If there is a comma and the world, like exclamation. So like that, we have different parts. I mean, all the words will be divided. I mean, breakdown like 4 words, like breaking down the text into smaller units. Like that, parts of speech tagging, POS tagging. There is a POS tagging is a library we have in NTLK, KT, NLKT of our library. There is a POS tagging. There is assigning grammatical categories to word. Like the cat sits on the mat or on the wall. When you say, generally, there we can tag the grammatical categories like the cat is a noun, sits is a verb, on is a proverb, like the mat, noun. So different we are going to categorizing the grammatical words. And also named entity recognition is there. So here identifying proper nouns like names, people, places, and organizations. Suppose there is a context like a text like Apple was founded in Silicon Valley. So here Apple is an organization, Silicon Valley is a location. So like we can classify this, identifying the proper nouns like name of the people, places, or organization. And what is parsing? The fourth one, the parsing, is analyzing the grammatical structure of a sentence. Like a sentence, if you take like the quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog. Here, the phrase, the tree shows how words related to hierarchical, the subject, verb, object, like that. No, that is a parsing here. And this, when you know the compiler designing, when you learned about the subject, there you can understand this what is parsing also. And sentiment analysis. The sentiment analysis determining the emotional tone behind the text. Sometimes I love this movie, then this is a positive. Or I love this, I hate this movie, is a negative. Sometimes we say it was terrible, so it's negative. So determining the emotional tone behind the text, whatever the given text, that is sentiment analysis. For everything, for every about this core concepts, we are going to experimental programs. Anyhow, I will show in this session. And the text classification is also there. Sixth one, that is categorizing text into three different classes. Like congratulations, you won a prize, like this class will be a spam generally. Because you know, we get the spam emails like that, where they are going to give like these spams, where they are trying to grab our information like that. So we can we can classify this this thing. When you are email got like this, you know, automatically it puts in the spam. And the mission translation, translating text from one language to another. Like okay, something. How are you? Eppadi irukeenga? Like that. So when you translate, this mission translation will be done. That's the texting, translating text from one language to another. And word embeddings, that is representing words as vectors, capturing semantic meaning. Like, you know, same like king and queen are close in vector space, reflecting their related meaning actually. And also you can go about language models, where predicting the next word in a sequence or understanding context. For example, the cat chased the, means automatically with the previous inputs, we can say the model might predict that mouse. The cat chased the mouse. So like that, they're predicting the next word, like language modeling it is. And information retrieval, the final one is information retrieval, that is finding relevant data or documents based on the query. For example, restaurants nearby in Google Maps, we can see that. So when you give this query like restaurants nearby, relative retrieves a list of local restaurants for this. So finally, the core concepts make the fundamental, the foundation of many natural language processing applications, enabling machines to understand and to process human language efficiently. This is the main core concept. All these 10, whatever we discussed now, this core concepts make the foundation of many NLP applications, enabling machines to understand and process human language efficiently. Okay, just we'll go again about this, what is natural language processing. Natural language processing is a branch of artificial intelligence that focuses on the interaction between computers and humans through natural language. The goal of the NLP is to enable computers to understand, interpret, and respond to human language in a way that is both meaningful and useful. And the applications, language translation, sentiment analysis, chatbots and virtual assistants, and more. And the natural language processing applications using AI, ML, and DL techniques. So, yesterday, uh, the Google CEO, Satya Nadella, is Microsoft, sorry. What is? He has given Gemini 3.5 version. You see, totally the trend is changing in the AI now. Okay, anyhow, I will at the end I will share the link about this. Okay, here we'll have a short look about the overview of NLP and its importance. This section introduces natural language processing and its a critical role in enabling machines to understand, intercept, and respond to the human language, highlighting the synergy between NLP and artificial intelligence, machine learning, and deep learning techniques. AI, ML, and DL techniques in NLP. This part delves into the specific AI, ML, and DL methodologies used in NLP applications, such as neural networks, transformers, and reinforcement learning, explaining how these techniques enhance language modeling, sentiment analysis, machine translation, and other NLP tasks. Applications and case studies. This section showcase real-world NLP applications powered by AI, ML, and DL, including chatbot, virtual assistants, automated content generation, and sentiment analysis tools, along with case studies demonstrating the effectiveness and impact of these technologies across various industries. NLP is a branch of, already in the beginning we discussed that NLP is a branch of AI concerned with processing and analyzing text data. Machine learning is a subfield of AI aimed at modeling data, and DL is a subfield of ML. So ML is subset of AI, DL is subset of ML. Okay, so that issues neural networks to analyze large data sets. NLP techniques may utilize ML and DL when used for classification of words, sentences, or even paragraphs. AI is a broader concept of creating intelligent machines with ML, deep learning, NLP, and computer vision are specific subfields of within AI. Natural language processing helps computers communicate with humans in their own language and scale other language-related tasks. For example, NLP makes it possible for computers to read text, hear speech, interpret it, measure sentiment, and determine which parts are important. NLP involves the use of artificial intelligence, ML, DL techniques to enable computer to understand, interpret, and generate the same what we discussed. So that I would like to jump to the evaluation of.
Excuse me, sir.
Yes, yes.
Sorry for the interruption. I request all the participants to turn on the camera. I request all the participants to turn on the camera. Thank you, sir. You can continue and proceed.
Okay, thank you. Yes, in the evolution of the NLP, we have past, present, and the future. You can see in the first phase, machine learning, automatically converting text from one language to another. For example, translating a website from English to French to reach a broader audience. Converting legal documents from Chinese to English for international lawyers. Translating subtitles in movies to different languages so viewers understand the context. And this is actually the first phase of this machine translation, and also information retrieval. Finding relevant documents or data in large database based on our queries. For example, searching for best restaurant in nearby that suppose New York on Google. Company employees searching their internal database for specific reports or files. A researcher querying PubMed for articles on some like deep learning or AI like that. So these are all the first phase evolution. There is a machine translation and information retrieval. At present, we have sentiment analysis. Sentiment analysis, detecting emotions or opinions expressed in texts. For example, analyzing millions of tweets to see if the public sentiment about a new product is positive or negative. Customer reviews on Amazon categorized as positive, neutral, or negative, helping companies to improve their products. And some other case, we have monitoring social media to gauge public mood during elections or crisis. And also, we have information extraction in the present scenario. Automatically pulling specific piece of structured info from structured text. For example, extracting the names of companies, dates, and amounts from financial news reports, and pulling key facts at medical reports such as patient age, diagnosis, and prescribed medication, something like that. And also, questioning and answering is there. The questioning and answering is developing system that answer user questions accurately by understanding the context, like asking a virtual assistant, like what's the weather forecast for tomorrow, and getting a precise answer, like asking customer service chatbot, how can I request my password, and receiving step-by-step instructions. These are all the question answering. These are all in the present scenario we are seeing. Okay, and the future outlook, when you say that is while the diagram does not detail the future techniques, okay, but I have some hints to explain to you. More contextual understanding, including suspense, humor, or complex emotions, real-time language understanding in live conversation. Now you know in Google Meet also they are introduced that real-time conversation within microseconds. The other people who are listening, their own language they can listen, whatever the language by the source, like that. Now it is in the Gemini 3.5 version. Okay, the future examples might include AI that can read and understand a medical journal, that counsel a doctor in a natural language, or virtual assistant capable of understanding nonsense human emotions and intentions. Like that, we can have in the future predictions and. What are the terminologies we related to natural processing? Phonology, it is a field that studies how sound is organized systematically. Morphology, it is a field that studies how meaningful words are constructed from primitive units. Morpheme, it is the basic unit of meaning in a language. Syntax, syntax refers to the set of rules which defines how the word can be organized the to form sentence and phrases. Okay, so these are semantics and pragmatics, world language, so world knowledge. So like that we have all these terminals will help you to understand the implementation of NLP because I would like to go to explain some practical approach so that this terminology can be included while we are discussing about the experimenting about the program through program. And here in this diagram I would like to illustrate that various components of language processing, natural language processing as a system. Here showing how different subfields work together to enable machine to understand, intersect and generate human language. Here are some examples I am explaining. That is the central idea is this natural language process. It is a core technology that allows computers to process and analyze large amounts of natural language data. The components and examples you can see here. The first one is managing human computer dialogue system, the green one. Okay, systems that facilitate smooth conversation between humans and machines, often via chatbots or virtual assistants. For example, virtual assistants like Siri or Alexa that understand spoken commands such as "What's the weather today?" and respond naturally. And customer service boards on websites that help solve problems without human intervention nowadays is going on, well. And also the next one is mission perception. Is the blue one, the mission perception. The system's ability to perceive the intercept human language and gestures, including speech, text, possibility, visual colours. So all this machine perception will take like suppose I would like to give an example. Voice recognition in smartphones that converts speech into text. Nowadays we are sometimes we use in the WhatsApp messages or some other just giving the voice message which will convert into text and we can send it. So this is already existing now. You may be experienced already. And smart home devices that understand commands like we have smart homes now. You want to switch on the AC, switch off the AC or switch on the fan, like that. You can turn on the light, like so many with the spoken language we can give. And also we have natural language generation. That is the system's ability to produce human-like language to communicate with the users or generate content. Just automated news report generates that write summaries of sports games or financial reports. Some automated generation of the text, you can do it. And Natural language classifier. It is ability to categorize and sort text into predefined categories like spam filters that actually filters the classifying emails as a small spam or not. Automatically it sends to the spam like and sentiment analysis systems that classifies reviews as a positive, negative or neutral like that is a natural language classifier and natural language understanding. That is a deep understanding of natural language, including context, sentiment, semantics, intent. Like an AI that understands the difference between book a flight to Paris and book a table at a restaurant. So it classifies actually. It understands what you are our intention to retrieve the information. Sometimes chatbots that interprets circles or nouns questions correctly, and the voice assistance understanding indicates commands like I am feeling cold and responding with the appropriate actions. Like so, these are all the different types of natural language process. And let's have a look at some examples how machine translates
Excuse
help
me, sir.
business. Yes.
Once again, sorry for the interruption, sir. Participants, kindly
No.
enjoy your video, revise on throughout the session to maintain the engagement and participation. Thank you, sir.
Okay. Thank you. Okay, we'll continue with the. We'll have a look at some examples of how machine translation helps for the business. You can see the Google Translate and this translation of more than 100 billion words every day, you know, and Facebook now, which is a Meta, uses multiple transactions to enable the automatic transactions of posts and comments, and this multiple transactions allows eBay to process cross-border transactions and the connection buyers and sellers worldwide. Microsoft pioneers, that is a state-of-art machine translation mechanisms powered by artificial intelligence aimed at helping Android and iOS users access convenient translation. And you can see natural language processing techniques evolving the NLP industry. You can see there is a human at the right side and robot at the left side. In between you have a laptop is a NLP. There you can see hi, hello. There the NLP converts into the mission language like to understand the mission, and it will again translate this information to the corresponding values like binary code snippets like 10001 like responding digital data processing, and the speech bubble suggests message or speech exchanged like that, and totally the understand and reply in kind, bridging the gap between human language and digital data. It emphasizes the interactive conversation aspect of NLP technology, and there are 5 steps including in NLP which are lexical analysis, syntax analysis, semantic analysis, discourse integration, and pragmatic analysis. So here lexical analysis is in this step the lexical analyzer categorizes the entire input text into words, sentences and paragraphs, And syntax analysis, almost in compiler designing, if you go through somewhat, you can understand these terms. Anyhow, here there is a clear explanation that is the syntax analysis is the process, is also called parsing. In this step, the syntax analyzer will check the input text for grammatical errors and semantic analysis. In this step, NLP checks whether the text holds a meaning or not. The semantic analysis. And discourse integration. The meaning of any sentence is greatly affected by its preceding sentence. Like that is a discourse integration. And pragmatic analysis, the analysis text is integrated with the real world knowledge, the extracting the actual meaning of the text. You can see how this NLP works. Already we discussed that lexical analysis, syntax analysis, semantic analysis, discourse analysis, and programmatic analysis. What is this? And here, for example, in lexical analysis, identifying word like running, dogs, or happiness, and breaking down a sentence into words, prefixes, suffixes, and roots for the further analysis. Here, this NLP works by utilizing computational algorithms and techniques to process and analyze human language data, extracting meaningful information, and embedding, enabling computers to understand, interpret, and generate text to speech. Here you can see this core technology enabling computers to understand and manipulate the human language, that's natural language processing. When you see that translation, that is, translates text or speech from one language to another. For example, translating an email from English to Spanish, converting a speech into Hindi to text in English for a global conference. So you can see the translation here. And after that, autocorrect. Corrects spellings or grammatical errors automatically. For example, typing receive, autocorrect to receive, like correct happened, like HAPP, NED if you type, you can say it automatically corrects HAPP, END like. So it autocorrects. You know, will automate nowadays when we are typing in your Word or emails or WhatsApp, auto correction is there. Reporting generates reports for specialized fields like marketing, clinical, like analyzing customers' reviews and automating the summarized reports. For example, summarizing 1,000 customers' feedback comments and the key themes like reporting, like marketing and clinical, like, and summarization, that is condenses long documents into short version. Summarization a research paper into a brief abstract, creating a summary of a news article for a quick reading, like summarization. And we have chatbots. The function of chatbot is engages in human like conversations, like customer support chatbot on websites, and virtual agents, that is a more advanced bot that assists with tasks. Like suppose booking a ticket on a travel website via chat, or for customer support, a chatbot answering frequently asked questions about product returns, like. And the semantic and sentimental analysis, we have positive sentiments, negative sentiment, and the numerical score examples, like, yeah, we can have an example programming. If time permits, we'll go through all the programs which covers all these applications. And language models, powers various language understanding tasks like parts of speech, tagging, optical character recognition, such thing. And overall, this scenario, imagine a healthcare company using NLP. They develop a chatbot that answers patient questions. They use semantic analysis to gauge the sentiment of patient feedback. They implement summarization to create a concise health report. During translation, a doctor in one country can translate patient record from their language into English. They also include auto corrections for electronic records to ensure accuracy. We can the natural processing applications evolving in the NLP industry. We have some examples to example programming. I will show you in the practice. And applications here, AI, resources, replications, like you can see here. A natural language resource encompasses a wide range of linguistic data, including corpora, lexicons, grammars, and unedited text, essential for tasks such as natural language processing and understanding. Suppose you can see here resource, the blue one, data sources and tools used in for ALP. For example, you have social media platforms like Twitter, knowledge base like Wikipedia or WordNet, and search engine like Google or Bing, cloud storage for data, like. And the purpose is provide the raw data and tools that NLP systems rely on the learn and process language. And also you can see that green one, the bottom one, that is representations. That is, it includes ways to encode and represent language data internally. For example, word embedding like word to vectors or glow vectors that converts words into numerical vectors. Programmers and algorithms that analyze these representations. Actually, it will be used for transforms raw language data into formats that AI models can understand and manipulate. And AI, that is uses statistical and machine learning techniques to analyze language data, sentiment analysis models, language models that predict next words, pattern recognition algorithms. Like the purpose of this one is execute the core intelligence requirements for NLP tasks, analyzing and understanding language data. And at the top we have the purple one is applications. This is the practical uses of NLP. You know that machine translations like Google Translate, and the chatbots and virtual assistants, text summarization, sentiment analysis for marketing. Actually, this purpose is real world deployment of NLP technologies to solve specific problems or enhance user experience. So the flow and interconnection is resource feed data into the NLP system, representations process and encode the data, AI applications algorithms to analyze and learn from the representations. The system generates output used in various applications. These applications often really on continuous updates from the resources. So this language process resources encompasses a wide range of for the natural language process and understanding. Here you can see the same information what we discussed about the machine translation, information retrieval, sentiment analysis, information extraction, question answering, where we discussed in the previous slides. And here the language, natural language principles uh, the main components. Here we have input sources. At the left side, you can see the NLP layer and the knowledge base on the top of the right, and also the data sources, the bottom of the right. Here, the input sources are represents various types of textual data such as social media posts, messages, emails, articles, apps, like that. These inputs contain natural language data that need processing. And when you this the center one is a NLP layer, natural language processing. Here this layer, the core component of NLP occurs. It analyzes and interprets the raw input data, uses linguistic techniques and algorithms to understand text meaning, context, and relationship. And when you come to the right top, the knowledge base, the source content like facts, definitions, and structures information provides background knowledge that can be referenced during processing and understanding. And data storage, simply keeps interaction history and analysis, details of fast conversations, and data patterns, what happened in the previous discussions, conversations, supports learning, improving accuracy, and contrast understanding. So, the natural language process principles are covered here, and it involves the development and application of computational techniques to enable computers to understand, interpret, and generate human languages. Again, this information retrieval, sentiment analysis, okay, information extraction, question answering, these are the tasks actually, NLP tasks. NLP task encompasses a variety of computational techniques and algorithms aimed at understanding, analyzing, usually generating and manipulating human language data. So yes, the same. And every beginner of NLP engineer must know these techniques, where already we listed the NLP techniques at the beginning, like tokenization, lemmatization, scheming, process speech tagging, word embedding, dependency parsing, topic modeling, term frequency, named entity recognition, text summarization, language translation, text classification, sentiment analysis. So these are NLP techniques evolving in the NLP industry. Already we had a brief discussion about these tokens, terminologies. We had a discussion already. Okay. So anyhow, now we'll have a practical approach, hands-on session. Here we can see the first program, that is tokenization. That is a process of breaking a stream of text up into words, phrases, symbols, or other meaningful elements known as tokens. So here is a code you have. Before that, you need to download the necessary library, that is NLTK, and you have to import that NLTK to your program, and there you have the term, the PUNKT you have to take, and from this import word tokenize. So this word tokenize is one of the library we are including in this one, and the text what we have, you can see this is an example of tokenization. This is an example of a tokenization. So when you use the function word tokenize and text. So you will get the tokens like tokens. So print tokens. You can see this is an example of like different. It is breaking the words sentence into words. So I would like to show this. The program. I think you can see this screen. Visual Studio. Here we have a program. The same content I was copied here. You can see we import NLTK, and also you have imported the word token from the NLTK tokenize, so that this the word NLTK tokenizer. Now you see this will tokenize your sentence. What is the sentence here? This is an example of tokenization. So it breaks this sentence into words like pieces of the symbols or the words or phrases, whatever may be. Just look at this one, and we'll have when you execute, what will be the result. So I think you can see the terminal in the bottom section. In the bottom section, you can see it is successfully executed, and you can see this output here. There is this is an example of tokenization and full stop. 1, 2, 3, 4, 5, 6, 7 parts. It is breakdown to 7 parts. Are you able to follow this? Are you able to look at this result after the execution of this program? This is tokenization. Okay, thank you, Doctor. Okay, here all these programs were included in our PPT, so that you can also practice at your systems. But one thing, you have to install all the required libraries and to make it successful execution. Okay, and see, you can run at your command prompt also. Like this, you will get this is an example of tokenized I. This is a full stop, like you will get, and this is about the tokenization and lemmatization. So, what is lemmatization? Is the process of reducing a word to its base or root form, calling a lemma. That is, stemming is a similar process, but it often results in words that not actual words. Here we are using in this program, write a Python program to perform lemmatization using NLT. Okay, so same you can see here. We use a word net lemmatization. Lemmatizer. Here we are giving running. We are giving running lemmatization here. Print lemmatizer, lemmatize, and the output will be running. Then when you print lemmatize, so you will get run. This run is the root form of running. So sometimes if you want to extract the root form or base form of the word, you use this lemmatization. So okay, we'll look at the program.
Excuse me, sir.
Yes.
Would you like to have few more minutes to complete your presentation?
Yeah, now I am in the practical part, hands-on session. Once it is completed, maybe there are 10 more programs. I will demonstrate these 10 more programs and it will be end.
Okay, sir. Thank you.
This is the last part of our session where I am, whatever we discussed about all the parts of the techniques we are using in the this NLP. So that we are going to discuss with examples of programming. So here this Lemurizer, which is in the NLTK, that is a natural language toolkit library. So here when you run this program, okay, I will clear this. So when you run this one, downloading the package WordNet, because from the WordNet only it is the WordNet Lemurizer function will be there, and you can see after the successful execution of this program, running is the phrase, I mean the word we are given. So again we are taking that Lemurizer as a base word is ran. Okay, so like that we'll get the basic word, I mean base word or root form of the word we'll get. So this is an example for lemmatization and stemming. Stemming in natural language processing, the stemming refers to the process of reducing a word to its base or root form. This is often done to group together different forms of words so they can be analyzed together as a single item. So you know, like here there is a simple program. We have running, runner. So these are all the same related words. I will show the example. Third one. So this is the program. Water stream. There's a poster stemmer. When we execute this, yeah, it is executing, and here it is giving run and runner. So where is it streaming the common related words, and it will giving. So where it will be useful for the grouping the similar words. So this is often done to group together different forms of a word, so they can be analyzed together as a single item. And another that is the parts of speech tagging. Parts of speech tagging. It's a part of speech. POS tagging is the process of making each word in a text with its corresponding parts of speech. Already we discussed, you know, what it is. I am learning NLP techniques in Python. So it tokenizes the word, and then each and every word belongs to which part of the speech. Like is it a verb or adverb or noun or preposition, like that. Okay, we'll have an example of this program. So you can see the average perception tagger. You can see here. I am learning NLP technique in Python. So what we did here, we imported NLTK library and we imported the post tag here, the post tag, and we used the post tag function to get the parts of speech parts. Okay, just look at this and we'll have a execution of this program. Yes, you can see now. Here I am given in the program, the text is I am learning NLP techniques in Python. So the post tag function will categorizes the parts of speech like I is a preposition here and am is a verb, learning is a verb, and NLP is a noun, technique is a noun, like proper noun, private noun, like we have all the parts of speech parts are there. So this is another part of the program. Here we have named entity recognition. NER is the process of identifying and classifying named entities in a text into predefined categories such as person names, organizations, locations, medical codes, time expressions, quantities, monetary values, and percentages like this. You can see this is a program here where we use NLT import the NE chunk is a library from NLTK. So first of all, you have to import the NLTK. So how you before that you have to install this pip install NLTK, like that you have to do. Otherwise, your system will not work. Okay. So for the named entity recognition, there is a program. We have the example text is Barack Obama was born in Hawaii, and we downloaded the NLTK data for analyzing and tokenizing the text with word tokenize, and also parts of speech we are using the position post tag here, and finally we are using named entity recognition. So we'll go to the program. So Barack Obama was born in Hawaii. How it will use the categorization of the sentence, you can see here. Yeah. So you can see our downloading package punk. You see downloading package average percentage tagger. You see downloading package max and here you can see all this downloading package punk. After that, here it is giving that Barack is a noun and it is a person. Obama is also the name person. You can see here the result here you can see. And was is a verb and born is a verb in. You can see this is like this all. You can see this is the noun Hawaii, that is GPE, that means geographical position on earth. GP is geographical position on earth, like that it is giving the location name or the person name or the entity name, like a product name, like that it is analyzing it with the named entity recognition, where you can find such as the categories, predicting the predefined categories like person names, organizations, locations, medical code, like that. You can give other example also. It will give you a thoughts of speech like. And sentiment analysis. Sentiment analysis is the process of determining the emotional tone behind the piece of text, whether it is positive, negative, or neutral. Like you can see, for that also you have to download the radar lexicon, where you can have the sentiment intensity analyzer is there. First you have to download the NLTK radar lecture, and also the example text is here. I love this product, it's amazing. Okay, and how it will be give for you the sentiment analysis, like the emotion, positive emotion or negative emotion or neutral. We'll go to the program. So that is here you see the text is, I love this product, it's amazing. Suppose I love this product, it is amazing. Suppose if I run it, if I execute this program, you can see it gives, its negative is only 0%, 0. Neutral is 0.26 and positive is 0.734 and compound it is a 0.8516. Okay, it gives the sentiment intensity analyzer how it is. Suppose okay, I will change the here I hate. Suppose I hate this product. It's worst. It's not amazing, it's worse. Okay. Now I am executing this program. Now you can observe that previously we have negative 0. Previously we have negative 0. Now positive is 0. I think you understand that how this sentiment analysis is going on, predicting like negative or positive. So sentiment analysis, just we came to know that. And next, text classifier. Text classifier. Text classifier is the process of assigning predefined categories or tags to a piece of text. We'll see this is a program. Better to understand this. Time is running out, so that I will show fastly. Yes, here I will try to show this one. So I'd like to show this result part. Yeah, I am showing this this one as a translation program, where it is collab because the environment is not supported for the Visual Studio, so that I set the environment to execute this program in Colab. You can also, I think you can use Colab also for executing the Python programs, so that all the libraries will be by default available in the Colab. Otherwise, we can install. Okay, here this is the program where you can translate, the given text. So now I am going to run it. So you can see that translation from English. Okay, I will give EN code for the English, and like example translation to, suppose I will give Tamil TA and type the text. How are you? You can see this program given in Tamil. I think you can read. Someone I can read like this. It will be translates, and also you can translate this. I think you can see this screen, how it is translated from English to Tamil, or you can translate it to again other language also. I will try to translate it in English to Telugu also. Okay, English EN, and I would like to translate to Telugu T. Same, how are you? Okay, మీరు ఎలా ఉన్నారు? Okay, so like this it will translate from one language to another language using this NLP. So this is the translation, is the main concept in the industry. And language translation just we discussed, and text summarization. So you give a big text, you see here, input the text. Here we have input the text. Text summarization is the process of considering a piece of text like this. Much more text is there. How can you summarize it? So within this text you can find here, the text is more than 6 lines, but we can summarize it with a short one. How can we do? So there is a program. Summarizing the text. You can see here, the big text is there, but it is summarized. Like the goal of summarization is to create a considered version of the like this. You see, very less. Actually, our text is how much text we have. You can see here, this much text. So we can summarize the text. This is one of the program, and the word embedding. Next one is word embedding. So in this you can see the positive, negative of the text, and how it will come out. You can understand that word embedding are a type of word representation that allows word with similar meaning to have a similar representation. So here we use word to vectors, and we will assign a similar numbers to that, and we will execute the program. You can see that the result will be like this. These are all the word vectors for positive and like this you can see. So I will show this program running. So all these programs are available in the presentation itself. I will share the presentation to the organizations. You can execute this one from your systems. You see, we'll get all the word vector for positives. Vector for positives will get it. So like that, they will be grouped the similar words to the vectors. So this is about word embedding using the word to vector or glow vector, and dependency parsing. Dependency parsing is the process of analyzing the grammatical structure of the sentence based on the dependence between the words in the sentence. Like you can see that sentence, I am learning LMP techniques in Python. So when you see that output, I is a subject and am is a auxiliary word and learning is the root and NLP is the compound. Like that, it parsing will done. Dependency parsing will be there. See in the program you can see that. Spicy, yes. Here you have to download this spicy library so that you can have this loading encode web sm so that you can have the dependency parsing can be done. So this is developed in the Colab. You can see this is the program here. That's import spicy, load the model, and we have I am learning. You can see this is I am learning NLP technique in Python, so that you will get the output like this. We'll see how the output will be generated. So you can see here the output is I am learning NLP. All this part you have a punctuation, or it is a proverb, or it is a compound or root word, or like that, subject, noun, subject, like that. We have different parts of speech you can do it. So this is the one program where explains about the dependency parsing. The process of analyzing the grammatical structure of the sentence. And topic modeling. Topic modeling is a method used in natural language processing to identify patterns and topics in the text corpus. One popular technique for topic modeling is a latent digits, a LDA allocation, which uses a statistical model to discover latent topics in a set of documents. In a set of documents, how can you take the latent topics? So this is a program here, vectorization and the LDA model printing and printing the topics from that given information. So here natural language processing, and this is a document you are given, all the document. You'll see the program output, how it will be. You can see here natural latent idea like this. Okay, we will see in the programming. So this is the program, already it is copied, and this is the text we have. This is the document, and it will use the topics. How it will use, we'll see. So here the topic one is natural latent idea processing modeling. Second one is natural processing statistics discover document, and third one is language computer NLP AIM enables. So these analyzes here, we can see this part, in this document part, it analyzes and gives the topics, the main core topics after analyzing it. So that is topic modeling. And the term frequency. Term frequency is a measure of how often a term appears in a document. It is commonly used in information retrieval and text mining. Already we know that TF, IDF, the term frequently inverse document frequency is a weighting scheme that assigns a weight to each term in the document based on the TF and the IDF. So here an example document you can take. This is an example document. It contains several words such as example and document. Everywhere we have to do the tokenization, and we use this TF. Like, yes, I will show the program. So this is an example document. It contains, you can see this, it contains several words such as example and like this. So now whenever we execute this program, you can see the counters all. This one time, okay, is one time, and one time, example one time, document. You can see that it counts how many words and how many times we have. Okay, we'll see how many several words. Example. So just word example like that I am given some other word which will give 2 times. Okay, we'll see. You see the occurrence here one example and here one. So like it gives the counters for the words in your document. So this is the term frequency. And backs of words, BOW, in natural language processing refers to a technique that represents text data by counting the frequency of words in document. Okay, I will show this simply. The program. 14th one, no. Yeah, 15th one, yes. You have to go here. Connect. Okay. Yes, anyhow, we have all the programs executed and they are available in the PPT. It will be supplied. So please, that the time is running out. What mechanisms enable NLP systems to identify the source and the target language for translation? Yeah, sir, for your question, I used some techniques in the program, the translation. Language translation here. We have to import the Google Trans from translator so that it is easy to identify the source there. That's why I use it in this one. That's why I use this Colab to execute that program. Okay, the advantage, efficiency, insight extraction, personalization, global communication, improved customer experience. Okay, you can understand all these things to going through the text, and generally we use the tools like natural language toolkit and Space AI, that is the another Python library to that provides efficiency NLP tools. Already we use, and transflow or NLP for the NLP we are using, and like we have so many tools we used already in the practical session, and the programs also I am sharing with you. Please go through that. So these are all the main processing tools we use. Yeah, the techniques and processing techniques what we use, and use cases, transaction applications, fake news detection, classifying emails, predicting diseases, error detection, IVR applications, sentiment analysis, personal voice assistance. All these finds applications in various domains such as these things. And we use applications in search engines, virtual assistants, social media analytics, healthcare centers, and e-commerce. Then we use okay, we have more, yes, this is about today's session, and I am apologize for this extending the session, and I am very thankful for your patience being with me. Thank you. And over to the organizer. Madam, you can conclude the session, madam. Thank you, Manoj.
Thank you, bro, sir.
Thank you.
Sir, shall we conclude the session?
Yes, yes.
Good evening, everyone. As we come to the close of today's FTP on NLP application using machine learning and deep learning techniques, I take this opportunity to express my heartfelt gratitude. First and foremost, I extend our deepest thanks to our esteemed chief guest, Dr. Shivaram Rajayagri, Associate Professor at the College of Computing and Information Technology, Saudi Arabia. Sir, your insightful session has truly enlightened us and opened new perspectives on the fascinating field of NLP. We are grateful for your time, knowledge, and inspiring words. I would also like to thank all the participants for their enthusiastic presence and active engagement throughout the session. Last but not least, a big thank you to the organizing team for their seamless coordination and efforts behind the scenes to make this event a success. Once again, thank you all. We look forward to seeing you in the upcoming sessions of this FDP. All the participants are requested to fill the feedback form which is shared. Thank you.
And thank you
Participants,
very much. Thank you very much for
participants can
asking.
fill the feedback form which is shared in the WhatsApp group.